Welcome to this explainer. Right out of the gate, I've got a challenge for you. I want you to think of a really stubborn, frustrating, bad habit that you've tried and totally failed to break. Maybe it's endlessly scrolling on your phone right before bed, stress eating when work gets overwhelming, or just chronically procrastinating on those big, important projects. You know the drill, right? You've probably made countless promises to yourself that tomorrow will be different, only to find yourself repeating the exact same behavior the very next day.
So it brings up kind of a painful question, doesn't it? Why do we always fail our resolutions to break these bad habits? Think about it. When you slip up, do you feel like you simply lack discipline? Do you tell yourself that you just need to try harder? Or maybe that you just have a weak character? We tend to carry around a ton of guilt about our inability to change our daily routines. But what if I told you that your failure to break that habit has absolutely nothing to do with your moral fiber and literally everything to do with how your brain is biologically wired? Okay, let's dive right into this. For decades, the dominant advice you've been fed is that willpower is like a muscle. In psychology, this was known as ego depletion. Basically, the idea that willpower is this finite battery that drains the more you use it. But here's what science actually says today. That theory has pretty much collapsed. A massive 23 lab replication study in 2016 found that the ego depletion effect essentially vanished. Yep, willpower is not a reliable battery you can just recharge. Neuroscience shows us that breaking habits isn't about mental brute force at all, it's about understanding neurological habit loops.
Section 1, the myth of willpower.
Look, I really want to completely validate your past failures here. Because when you make a highly rational plan to stop eating junk food at 9 a.m. and then completely abandon it by 3 p.m., that is a biological reality, not a moral failing. Here's the biological catch. Even if willpower were a muscle, it relies entirely on your prefrontal cortex. That's the rational, executive planning part of your brain. But basic neuroscience tells us that when your amygdala fires off a stress response, it completely hijacks that prefrontal cortex. This means the rational planning center of your brain literally goes offline when you're stressed, hungry, tired, or anxious. Relying on your prefrontal cortex to stop a bad habit when life gets hard isn't an actual strategy, it's basically just a wish.
Section 2, Anatomy of Habit.
So if willpower is totally out of the equation, what is actually happening in our heads? Well, to fix the problem, we need to shift our focus away from mental force and look at the fascinating neuroscience behind how biological systems form our habits in the first place. It all comes down to what neuroscientists call reward-based learning. See, your brain evolved with one main priority, keeping you alive. And to do that, it uses this elegantly simple, ancient learning system: trigger, behavior, and reward. You see food, you eat food, you feel good, and your brain remembers it. This system is so fundamental to survival that scientists can observe the exact same mechanism in sea slugs, which only have about 20,000 neurons. But here's the catch. Your brain really doesn't distinguish between ancient survival rewards and modern ones. Finding a calorie-dense berry out in the wild gives you a hit of dopamine, sure. But so does the ping of a push notification or doom scrolling on social media to numb out your anxiety. And this is absolutely crucial. Relief from discomfort is logged by your brain as a reward. Your brain doesn't care if that dopamine comes from a pure survival instinct or from a smartphone. It just logs the relief and says, hey, do this again. Now, what's really interesting about this is how the reward cascade actually operates. When you do something your brain codes as rewarding, whether that's eating sugar or checking your phone, dopamine neurons fire in the ventral tegmental area and release dopamine right into the nucleus accumbens. I know, big words, but basically, this massive chemical release stamps that experience with a biological do-this-again tag. Over time, as this cascade repeats over and over, the behavior just slips right below your conscious awareness.
Section 3, rewiring the brain's circuits.
And this brilliantly illustrates what happens next. We've talked about the chemical cascade, but when you repeat these dopamine-driven loops over days, months, or years, they physically alter the geography of your brain. As a behavior shifts from a conscious, voluntary choice into an automatic compulsion, the active circuitry in your brain literally shifts its geographic location. It moves from the ventral striatum, which handles goal-directed behaviors, over to the dorsal striatum, which is the area responsible for deeply ingrained habitual actions. You are physically moving the behavior into the automatic, effortless part of your brain. It's absolutely wild. These habits leave such a profound, lasting mark on the brain's circuitry that scientists can literally spot them in a petri dish. A study from Duke University looked at mice that were trained to form severe sugar habits. When examining their basal ganglia, researchers found that the GO pathway, those are the neurons that trigger the action, had a massive, highly visible head start over the stop signals. The habit had fundamentally rewired the physical tissue to favor the compulsion.
To add to that, researchers at Northwestern Medicine investigated how dopamine actually connects these different subregions of the striatum. They looked at the ascending spiral, that's the pathway allowing goal-directed behaviors to become automatic habits. But amazingly, they also found evidence of a descending spiral. The circuits go both ways. Information can flow from the habit-related regions right back to the goal-directed regions. This is a massive clue for us. It tells us that because the circuitry is a two-way street, we actually have a biological pathway to break these bad habits.
Section 4. How cues trigger behavior.
All right, now that we understand the deeply wired circuits in our brain, we need to look at the real-world cues that hijack these systems on a daily basis. What actually kicks off that dopamine cascade before we even realize what we're doing? Well, there are powerful environmental drivers of mindless habits, primarily time of day, emotional state, and familiar locations. Take time, for instance. You might have a mindless afternoon snacking habit, but if you really pay attention, you might realize you aren't actually hungry at all. The time of day is just acting as a subconscious trigger for boredom, and the snack is the reward your brain is seeking to break up the monotony. But honestly, location is probably the most powerful driver of mindless habits. We mentally assign habits to specific places. Your home, your couch, your office desk, they all have pre-existing behaviors chemically assigned to them in your brain. And this is exactly why building a new habit or breaking an old one is so much easier in a new location. A new environment acts as a completely blank slate, freeing your brain from having to overcome those deeply ingrained location-based triggers.
Section 5. The 3 gears approach.
So, the crucial point is, how do we actually use all this neuroscience to our advantage? Well, Dr. Jud Brewer, an addiction psychiatrist and neuroscientist, developed this incredible 3-step clinical framework to solve this biological hijacking without relying on that whole willpower myth. Gear 1 is to map the habit loop. You have to clearly identify the trigger, the behavior, and the results. Gear 2 is to get disenchanted. Pay close attention to the behavior and ask yourself what you're actually getting out of it. Like, does doom scrolling actually relieve your anxiety, or does it just make it worse? Gear 3 is the bigger, better offer, substituting the old behavior with a new, more rewarding quality of mind. And you know what? The data completely backs this up. Clinical research using this exact framework resulted in a massive 67% reduction in anxiety scores. Because anxiety is the engine driving so many of our mindless habit loops, targeting the neural mechanism of the loop itself is incredibly effective. It dramatically outperforms those surface-level tips and tricks that just try to rely on sheer willpower, and it actually leads to lasting behavioral change. So, what's the secret weapon for that bigger, better offer in Gear 3? It's curiosity. When you feel an urge, instead of white-knuckling your way through it, just get curious about it. Ask yourself, what does this craving actually feel like in my body right now? Shifting your mindset from a tense, panicked, oh no, an urge, to a relaxed, inquisitive, oh, interesting, actively engages the brain's reward circuits. Curiosity is intrinsically rewarding to the brain. You are literally offering your biology a deeper, more satisfying reward than the fleeting distraction of a bad habit. As we wrap things up, I want to reflect on a quote from the pioneering psychologist William James. When we look at living creatures from an outward point of view, one of the first things that strike us is that they are bundles of habits. You see, habits are an essential part of our biology. They exist to allow us to conserve cognitive energy so we can actually navigate a really complex world. They aren't inherently evil. They're just a deeply wired system that we can finally understand and manage. So I'm going to leave you with this question to think about. What habit will you get curious about today? You now have the knowledge to completely ditch the willpower myth once and for all. You aren't broken and you aren't weak. Your brain simply needs an update based on reward value. So step out of autopilot, lean into that curiosity, and start actively rewiring your daily routine. Thanks for hanging out with me for this explainer, and I seriously can't wait to see how you put this neuroscience into practice.